Yo, what's up, everyone? Here's our second review set, and this is going to be optional. Um, and I'm pretty much just going to sound like a broken record because I'm going to go over 10 factoring and completing the square questions, talking about as hard as it can be. But all of this we've done before, and if you don't watch it, it's not the biggest deal if you feel really good about factoring and completing the square. So on the test, this is still going to be mandatory stuff. What I want you to think, or like the way the test is going to look, is it'll start with just no graphing, doing the skills, and then it'll end with like 4 graphs at least. Okay. So you'll start the test by warming up yourself by factoring, completing the square. And I'm just going to go through all 10 of these questions right now. And I think it'll be pretty quick, honestly, because we've done it all multiple times. So first, we want to turn these equations into factored form. So for the first 6 questions, we're in standard form or special form, and we want to turn it into 2 factors, okay? And we know that the easiest way to do this is if there's no leading number. That's the first thing you look for in a quadratic. So this is a leading number, this is a leading number, etc. Without a leading number, it's really easy. You find 2 numbers that multiply to this, that add to this. And I'll go a little slower because what can be hard is when you have like negative x or a small number here. But because negative 42 is negative, it's going to be a positive and negative number. So think that if the difference is only 1, those 2 numbers are always really close together. Okay, so that's the way I like to think of that. And because we can factor this the easy way, all we do is we take those 2 numbers and add them to x, and that's our factored form. So that's the easiest possible thing you could get. Probably could have done that before this class. But now I want to talk about factoring with the leading number. So that leading number makes it way harder because we have to do the thing where we split the middle in half and then find our greatest common factors. Okay, so there's only one long method. So you just have to remember the long method. And it starts by, instead of factoring this outside number, you multiply the outside number to the leading coefficient, and that's what you factor. This should say negative 15 because it's got to be negative 60. And 60 I use constantly because there's so many factors here, but we know that one factor is 4 bigger than the other factor. So it's going to be negative 10x and 6x because we know negative 10 plus 6 gives me negative 4. Okay? And because it's the long method, we replace this negative 4x with those 2 numbers. And then do this. And I think if you can get yourself to this step, putting the line in between, then you're going to succeed, right? The hard part is remembering to do this. Then we look and find the greatest common factor between my numbers. So both of these are divisible by 2. And we can take away an x from both of them. If we take 2x away from 4x squared, it leaves us with 2x and then negative 10 divided by 2, which is negative 5. We do the same thing over here. 6 and 15 are 3s. And then it is going to line up. So then you just take those greatest common factors, that becomes one of your factors, and then what they have in common becomes the other one. So I wrote it really quickly, but again, this and this have to be the same. If they're not the same, you did it wrong. And then you use that as one of your factors, and then the 2x plus 3 comes from the greatest common factors. So number 3, we're going to do it the same way, but what I want you to notice is that the leading number here is negative, okay? And if the leading number is negative, and we're going to see an example in both this and completing the square, it's not going to be too consequential, okay? Let's start it the same way. We're going to take the negative 3 and multiply it to the 8. And we need 2 numbers that multiply to negative 24 and add up to positive 10. Because that middle number is positive, it's going to be a bigger number that's positive minus a smaller number. So it's 12x and 2. And then we're going to replace the middle with those numbers. Now, if you have this negative in the front, there are a few ways that you could deal with it. But know that it is going to be the same technique. Okay, and on the test, I wouldn't give you an example like this. I'll even call this extra credit right now. I would definitely give you, and we're going to talk about it, a completing the square with a negative, but I wouldn't give you one here. But either way, all you have to do is the same thing. -3 and 12 share the number 3. They both share x, but then what's going to be on the inside here is negative x, because -3 divided by 3 is -1. So all it's going to do is make one of my factors have a negative. Then you can do 12x divided by 3x to give you +4. Here we can do the same thing. They both share the number 2. And if this is +2, then the inside has to be -x. And then 8 divided by 2 gives me 4. So that's how you could factor it. And if you did it on your own, you might get negatives in different places. You could even distribute the negative out beforehand. But yeah, so that's that. For number 4, I just want to talk about how we could try to approach this with the shortcut method, because I talked about the shortcut method a bit. But you could always do the long way, but it's definitely cooler to try to do it in your head. And actually another teacher taught me this, and I always thought it was very cool. The gist is if we start with a 3x squared, we already know that my factors are going to be 3x and x, because the first 2 terms of my factored form give me the leading number. And there's no way that we can split the 3 up without the front not equaling 3, right? This couldn't be 2 and x or 2 and 2, because that wouldn't multiply to 3. So this and this have to multiply to that. And then this and this have to multiply to that. But then also, when we do the inside and the outside, add up to 17. So here, all I'm going to think is that there aren't that many options. It's going to be +1 and +10, or +2 and +5. And we can actually just put them both in. This example is easier because everything's positive. That's kind of why we're doing a shortcut here. But I'm going to plug values in and see if they work, and then just erase. So this first one worked. So that's kind of a bummer. But it works because 3x times 5 is 15x, and 2 times x is 2x. So 15x plus 2x would give you that middle. So if you're really good at this unit, you can start shortcutting as much as you want, because at the end of the day, a lot of times we do this math just for your standardized tests and speeding through them, honestly. Actually, I'll delete that because you don't need to speed through standardized tests. Okay. I'm honestly even getting... Okay, so for number 5 and number 6, we have 2 special quadratics. And the key to both of these is that you need a negative sign on the inside. But if we have perfect squares, meaning only numbers that you can find the square root of, all you have to do is square root the front number and the second number, and that's going to be your factors. So what I mean by that is x squared, we're going to split up the x's, and then 144, the square root of that is 12. And I think my explanation is not that good here, but hopefully it really makes sense what's happening, right? If we do this, I think it'll totally make sense. The leading number is 100x squared. So we just want to take the square root of that entire thing, which is 10x, right? 10x times 10x gives you that. And then the square root of 81 is 9. So those are the 2 square roots, and you do the positive version and then the negative version. Okay? So that's easy. Because I'm on Zoom, I have no idea how much time it's taken. I wasn't paying attention. but I think it's going pretty quick. But now we're just going to talk about the other way to do this, or the other way that we can change the standard form, which is by completing the square. But before that, I just wanted to do a FOIL example. It doesn't even work right here, but actually on the test, I will ask you to FOIL one example. And all FOIL means is we want to go backwards. We want to go from the factored form in the last example to the standard form, something that looks like this. So you take your first two numbers and multiply them together, your outside numbers, your inside numbers, and your last two numbers. Once you have that, this is the first term, this is the last term. You just do the middle, like add them up. So negative 7x plus 4x. And that'll give us standard form. So yeah, that ties more into the first set. FOIL is the opposite of factoring. But yeah, I think that's our easiest skill. Now let's tackle completing the square, which is pretty difficult even if you don't have the leading number. But remember that, we complete the square when we can't factor. So even though in the real world, you might not know whether or not you need to complete the square factor, I am going to tell you. Okay, so just read the question to see what it tells you. And if we want to complete the square, we're going to take those first two numbers and find a replacement outside number. That's the strategy. So I move away the 60 because it wasn't useful. And then I look to add a number here. And that number is 49 because it's the inside divided by 2 squared. But I think that's hard. So my strategy is figure out what it's going to factor to before I figured out the number we added. Because two numbers that multiply to 49 that add to 14 are 7 and 7. So this is the right side of my equation. We finished the right side. On the left side, we have to add 49. Because if you do something to one side of an equation, you have to do it to the other side. So 49 minus 60 will give me negative 11. And then we just move that number over to the other side. And we have the vertex form, which is another great form. The bad form, good form. Let's do 9 and 10. The last two examples, maybe the hardest. We got that leading coefficient, okay? It doesn't affect our first step, which is move over the 45 to the other side. But this step is hard, or really the next step. We're going to get rid of the 3, okay? Think that that leading number is going to become the slope of my vertex form. And if we do that, if we take away the 3 from both of my numbers, this looks just like this example, right? So we have an x squared minus a number. We can divide that number by 2 and then figure out what it factors to. We kind of ignore the 3 for now. We took it away, it becomes the slope. We divided the middle by 2 and then we square it. And that's what the right side looks like. The complication here, the thing that people will forget, is that we added 16 to this side, but we have to add 48 to this side. And the reason is that 16 is being multiplied to 3. Right? It's just hidden in parentheses. But this expression means that we really added the number 48 to this equation. So 48 minus 3 will give us, 48 minus 45 will give us 3. We'll bring the 3 to the other side. And that's that. This last example has a negative and it looks absurdly big. So always have your calculator or phone calculator ready in case that's the problem. But if you don't have to graph it, the numbers can be way bigger. So all I want you to see here is that the negative is not really going to affect the equation. We want to get rid of whatever is in front of it anyway. So we're going to divide both my first term and my second term by -8. So it's going to be plus 16. All the negative did, it really doesn't affect this kind of question a lot, which is why I'll probably give you one like this. You take away the negative and then figure out how you'd complete the square on the inside, ignoring it. So it becomes x plus 8 squared and then plus 64. And then you're gonna have to do -8 times 64, which is 512. And it's close to this number, so that should reassure you. But what's funny is I kind of messed that up. But yeah, the question at least. Actually, no, I didn't. So here, the only thing that's going to get messed up by this negative sign is that we're not going to add a number to the other side. We're going to subtract a number because what's really being added over here is -8 times 64, which is -512. So hopefully that makes sense to people. It means that 9 is on this side of the equation. And then we bring the 9 over to finish. Okay. I think I went through that last example kind of quickly, but hopefully it makes sense to everyone. Hopefully this whole worksheet makes sense to everyone. That's why I can't zoom out, it messes up, but oh, it came back this time. But yeah, I appreciate you, and I'm honestly exhausted by these topics. We've talked about them for so long. I'm excited to be done with completing the square and factoring. Yeah, so onward to the next unit after the test. I hope you feel good about the test. But yeah,